So hello friends, welcome back to our channel Adamya Education. So today we are going to solve the 2020 ICSE question paper from the subject physics. So like we have been doing in the past few live sessions, that first we solved section 1 in one of the live session and then we moved to section 2. So we are going to do the same today. Today we are going to solve the section 1. So let's begin with the questions. So your first question is, you have to define the moment of force. You know moment of force is also known as torque. So this is a direct question. Hello Gurleen, welcome back. You have not been there since quite a few days. I thought that you must have been busy because your exams might be coming very soon. But it's okay, thank you for coming. So let's begin. So define the moment of force. It is a very direct question, so I'm just reading it out for you. It is given in your book in a very clear manner. The moment of force or torque is equal to the product of the magnitude of the force and the perpendicular distance of the line of action of the force from the axis of rotation. So whenever we talk about torque or the moment of force, we will always consider rotational motion, and the force applied on one of the ends and its length from the point of rotation, that product will be known as the torque or the moment of force. And you also know that its SI unit is Newton meter. So now the second question is related to that itself. Write the relationship between SI unit and CGS unit of the moment of force. So the SI unit is Newton meter and the CGS unit is dyne centimeter. So let us see what is the relation. We know that 1 Newton meter can be written in this manner, 1 Newton into 1 meter. So 1 Newton means 10 to the power 5 dyne, which is the CGS unit of force, and meter can be converted into centimeter, 10 to the power 2 centimeter. So your final answer comes up to 10 to the power 7 dyne centimeter. So this is the CGS unit of moment of force. So this is the basic relation. You can directly write it like this, or you can also show it, because I'll always tell you no need to memorize things. Try to do it by practicing and recapitulation. So no need to memorize, or if you already know it, you can directly write the relation without showing any steps in between. Let's move on to the next question. Define a kilowatt hour. This is the unit of electrical energy. So let's see what is the definition. 1 kilowatt hour is the energy spent by a source of power 1 kilowatt in 1 hour. So if you are using an appliance or an electrical device which consumes a power of 1 watt and it is used for 1 hour, the amount of energy that it will require or it will consume, that will be known as kilowatt hour. So how is it related to joule? There is a direct relation for that. So 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule. Very important relation, because on the basis of this many a times numericals are also asked in the examination. So this relation you have to remember. Now let's move on to the next question. A satellite revolves around a planet in a circular orbit. What is the work done by the satellite at any instant? Give a reason. A very direct question once again from the second chapter. So you know one thing, that whenever a satellite or a planet is revolving around some other planet, or let us consider the sun itself, it is rotating, it is revolving because of the centripetal force. So centripetal force is the force which is applicable in this case. Now you know one more thing, that the relation for work is F into S cos theta. So this theta is actually the angle between the displacement and the force. So in the case of a satellite moving around in a circular manner, the centripetal force is always in a direction perpendicular to the displacement. So if the angle is 90 degree, the value of cos 90 degree is 0. So the work done will also be 0. So as a result, no work is done in this case. Satellite, whether it is even if it is revolving in a circular path, it appears as if it is doing some work, but actually it does not do any work. So you can either write it till here, or you can also show the mathematical expression and expect that your marks won't be deducted. So I would suggest you write the entire thing, because it is not very difficult to remember or understand. Now let us move on to the next question. So give one example where chemical energy changes into electrical energy. So a very common example, we know in a battery, what happens in a battery, we have chemical energy stored in it in the form of the electrolyte or the paste like substance which is present inside. So we can consider a battery or a dry cell. I guess a dry cell will be a much better answer. So a dry cell which we use in our remotes and all. And our next question is, electrical energy changes into sound energy. This is also directly from the book. The answer will be loudspeaker. You can also consider electric bell, because in an electric bell you know that as soon as we tap on the switch we can hear sound. So electrical energy is converting into sound energy. So both can be the answers here. So this is also from the chapter I guess work, energy and power. Yeah, from the second chapter. Alright, let's move on to the next question. There was another question, question C, question number D, which was given in the question paper, but it is not there in your syllabus now. It is from the chapter machines. It is related to levers, so I have skipped it. Now let's move on to question number 2. A crane A lifts a heavy load in 5 seconds, whereas another crane B does the same work in 2 seconds. You have to compare the power of crane A to that of crane B. A very direct question once again, and a very easy one too. Let's see how do we do it. We know that power is equal to work by time. So in this case both the cranes are lifting the same load, so they are doing the same work. So let me write for crane A, for A and for B. So you have been said compare. Compare means you have to find the ratio. Always remember that. In your question paper you will be asked to compare between a lot of things, like for example you might be asked to compare between the kinetic energies of two bodies, or between the refractive index of two transparent medium. So whenever comparison has to be done, it has to be done in the form of a ratio. Okay, so for A, the work, let me consider the work to be W. So power of A will be equal to work by time. So our time was 5 seconds, so W by 5. Similarly, the power for B will be work by the time for B, that is work by 2 seconds. So this is the power for the respective cranes. So let's find the ratio. PA by PB is equal to W by 5 divided by W by 2. So W and W, the work gets cancelled. So we are left with 2:5. This is the answer. I hope this question is also clear. A very important question from your exam point of view, because these type of simple questions are only generally asked. Don't expect that you will get very tough questions related to very complicated equations and all. No, you will get very simple questions which you can just see and solve. You don't have to put a lot of effort. Now let's move on to the next question. A ray of light falls normally on a rectangular glass slab. So let me first make a rectangular glass slab and then let's read the rest of the question. So this is a rectangular glass slab. Alright. So a ray of light falls normally on it. Normally means at an angle of 90 degree. So you have to draw the path of the ray till it emerges out of the slab. You know one thing, that whenever a ray of light is falling on a transparent medium at an angle of 90 degree, it will not show any refraction. It will directly move through the same angle and pass out of the other face. So your final diagram will be like this. It is moving perpendicular only. It is not showing any deviation from its path because the angle is 90 degree. Just imagine, for such a small diagram you are going to get 2 marks, and 2 marks is not a small thing. So this is the answer. This is the required diagram. Very simple. So I guess this is also clear. Let's move on to the next question now. Complete the path of monochromatic light ray AB incident on the surface PQ of an equilateral glass prism PQR till it emerges out of the prism due to refraction. So over here, as you see, it has been already mentioned in the question that PQR is an equilateral triangle and AB is a ray which is incident on the face PQ. But you can also see one thing, that you don't have any angle given to us. So we cannot consider that over here we will have total internal reflection or anything like that, because nothing has been given. We have only been said that PQR is an equilateral triangle. So it will just follow the basic path like we know. First of all, it will move into this and we are going to draw a normal, and then it will just move outside. The same diagram which you use to prove the formula in case of a prism. The same structure you are going to draw here. It is just moving into and coming out through the other surface without suffering any sort of total reflection as such. Okay. But if angles would have been given, then we had to calculate, we had to see if the critical angle criteria is getting met or not. But over here we don't have to make any such considerations, and we can make the normal diagram which we know, which is known to us already. Okay. So this is question number C. I hope it is clear to you, a very easy one. Now let's move on to the next question. Where should an object be placed in front of a convex lens in order to get an enlarged real image and an enlarged virtual image? Make sure that you are reading the word real and virtual properly. Don't just close your eyes and write anything you wish. You have to check whether it is given for real and whether it is given for virtual. So let's see. So you know one thing, that in a convex lens we get an enlarged virtual image, or basically we get a virtual image only in one condition, when the object is between. First of all, I am doing question number 2 because it is much more obvious. So enlarged virtual image, we get a virtual image for a convex lens only under one condition, when the object is between our focus and our optical center, so between F and O, then we get a virtual image, right? Now for our first question, an enlarged real image. We get real image in almost in all of the conditions except for this one. But when is it enlarged? There are two conditions. I am going to write the more obvious condition: between the focus and the center of curvature, between F and 2F. In this condition, you are going to get the image beyond 2F and it is going to be enlarged. There is another condition in your book where the object is placed at focus. We are going to get the image at infinity and it is enlarged, but we don't actually see the image as such, right? Because it is formed at infinity. We don't know where infinity is, or even if we can see it, it will be very, very large and it will not be clear also. So we are going to consider this condition between F and between F and 2F. So make sure that you are practicing the ray diagrams very nicely, because you will have almost 3 marks question from that chapter itself. So make sure that you are practicing it nicely and you know where the object is placed and where the image is forming for respective criteria. Alright, then let's move on to the next question. This is from the chapter refraction. A pond appears to be 2.7 meter deep. That means this is the apparent depth. Appears means which looks like, it is not the truth. Okay, it looks as if. So the apparent depth is given. Let me write it. So the apparent depth is 2.7 meter and the refractive index is given as 4/3. We have to find the real depth. So we know the relation that the refractive index equals to real depth by apparent depth. So we are going to use this simple formula here. So our refractive index is given as 4/3. The real depth, I am taking it as R, and the apparent depth is given as 2.7. So the value of R will be 3.6 meter. So 3.6 meter is the real depth of the pond, but it appears to be 2.7 meter deep. A very easy question based on a very simple formula. I hope you have understood this question also. Hello Pallavi Vishnoi, welcome to my live session. Let's move on to the next question now. The wavelengths of wavelengths for the light of red and blue colors are nearly 7.8 into 10 to the power minus 7 meter and 4.8 into 10 to the power minus 7 meter. So you have been given two values of wavelength for red and blue light respectively. You have to say that which color has a greater speed in vacuum and which color has a greater speed in glass. Okay. Very easy question. You know, in vacuum, electromagnetic radiation moves with a velocity of 3 into 10 to the power 8 meters per second. Be it visible light, be it UV radiation, be it infrared radiation, whatever electromagnetic radiation is there, it will always move with this particular speed in vacuum. So there is no point of saying greater speed. Both of them will have the same speed in vacuum. Okay. Same speed in vacuum, but in case of glass we have to consider. So let us see what we can do about it. So we know the formula is C equals to F lambda, and we see that C is directly proportional to lambda. That means the speed of light is directly proportional to its wavelength. So out of blue and red, we see that red has a larger wavelength, isn't it? So red will have a greater speed also, because speed and wavelength are directly proportional to one another. Okay. Hope you have understood this question also. Now we have another question from the chapter sound. Let us see. Draw a graph between displacement from mean position and time for a body executing free vibration in vacuum. Free vibration means there is no external force. That means the body can vibrate on and on until and unless we stop it, or if there is no stopping force, it will just move on endlessly. It is not possible in real life, as you already know, and it has also been said that it is in vacuum. That means until and unless the human force is applied, we cannot stop it. In vacuum there is no other resistive force. So the diagram will be very simple one. So let's draw it. So on the y-axis, on the x-axis we have time, and on the y-axis we have the displacement. So your diagram will be as such. The amplitude is not changing throughout. The amplitude is not changing throughout, and it is moving endlessly. It is going on endlessly. Okay, because it is a case of free vibration without the presence of any resistive force. So this is your required diagram. Hope it is clear to you. Let's move on to the next question. A sound wave traveling in water has a wavelength of 0.4 meter. Is this wave audible in air? Let us check. Let us find out the frequency, because you know that for a sound to be audible, it has to be between 20 to 20,000 hertz. So let us check whether the frequency of our wave falls under this category. So your wavelength is given as 0.4 meter and speed is given as 1400 meter per second. So we know C is equal to F lambda. So 1400 equals to F into 0.4. So F is equal to 3500 hertz. So yes, it does lie within the audible range. So this wave is audible in air. So you have to write this thing also, that the frequency of our required wave is 3500 hertz. As a result, we see that it falls inside the criteria for audible range, and as a result it is audible in air. So don't forget to mention these small things, otherwise you will lose marks. If the examiner who is checking your question paper is in a mood to cut marks for every small mistake you do, in that case you might lose marks. So don't leave any space for those people to cut your marks. Make sure that you are writing everything nicely. Okay, let's move on to the next question now. So both the questions I have written the answer. I'm just going to explain it to you. Both these questions are very directly asked from the book itself. Why does stone lying in the sun gets heated up more than water lying for the same duration of time? So this is from the chapter calorimetry. So you know one thing, you have studied about this in class 9 also, that water has a very high specific heat capacity. That means in order to heat up a small quantity of water, you require a very high amount of temperature. Or you can also consider it in this way, that whenever you are heating the same amount of water and the same amount of some other substance, water will take more time to heat up compared to the other substance, because in order to heat a very small fraction of water also, you require a very high amount of heat. Okay, the same criteria, the same concept can be used here. So what has been said, let's see. The specific heat capacity of water is very much higher than that of stone. Even in this question, in place of stone, if we had sand, we could have written the same explanation. So because of this high specific heat capacity, water will require a long time to heat up to the same extent as compared to stone. But stone will get heated up quickly. And in the same way, water will also take a long amount of time to cool down. And you know that this is the reason for the cool climate in the coastal areas. So this concept has been used here. So as a result, we can say that a stone lying in the sun for the same amount of time will get heated up quicker as compared to water. Okay, let's move on to the next question now. Why is it not advisable to use a piece of copper wire as fuse wire in an electric circuit? First of all, we cannot use copper as a fuse wire. Advisable is a very wrong word used. Okay, but since it has been asked, let us explain. So you know one thing, that for a material to be used as a fuse wire, it has to have high resistivity and a low melting point, because you know that fuse is based on the heating effect of current, because fuse wire will melt due to excessive heat flow, and as a result the circuit will break. Okay, so what happens in case of copper? The resistivity is low. Copper can very easily allow electricity to pass through it, isn't it? So resistivity is low in case of copper, and it also has a very high melting point because it is a very good metal. So we cannot use it as a fuse, right? Our device will completely get burned, it will get charred due to the excessive heat, but copper will still not melt. So what's the use? So you cannot use copper as a fuse wire. Rather we use an alloy of tin and lead, which is known as solder. You have studied about this in chemistry also in the chapter metallurgy. So we are going to use that as the fuse wire. I hope it is clear to you. Very easy questions, right? Very direct questions. If you have studied the book nicely, then you can very easily get like full marks in your physics exam. Okay, let's move on to the next question. Very easy once again, and one of my favorite things to do, finding out the resistance of these type of networks. Okay, let's do it. So we have to find the total resistance across AB. Let's do it then. First of all, we are going to simplify it to find the series connection. So we see over here that these two are in parallel, isn't it? So let me name it as R1, R2, R3. Make sure whenever you are getting these type of questions, you are making the diagram in your copy. So R1, R2, this is R3. So first I am going to write R1 and R2 are in parallel. Don't forget to write these things. Don't directly move on to the questions. They are in parallel. So we know that 1 by Rp will be equal to 1 by R1 plus 1 by R2. So let's do it. Three by 6, that means half. So Rp comes up to 2 ohm. The equivalent resistance of this parallel combination is 2 ohm. Okay, I hope it is clear till here. Okay then. Now we see that this equivalent resistance, which came as 2 ohm and 5 ohm, they are in series. So what I am going to write, I took the total resistance in the previous case as Rp. So Rp and R3 are in series. Write these things, okay? It also makes the examiner feel peace that okay, the student has written everything. I will give him or her good marks. Are in series. So our R equivalent will be equal to Rp plus R3. We are going to simply add it up as you know the formula. So 2 ohm plus 5 ohm. So your answer is 7 ohm. So this is the equivalent resistance of the circuit. I hope this question is also clear. Very easy one. Okay then. Let's move on to the next question. This is again from the chapter calorimetry. Two metallic blocks P and Q have masses in the ratio 2:1 and they are supplied with the same amount of heat. If the temperatures arise by the same degree, compare their specific heat capacity. So again you see the word compare, that means you have to find the ratio between them. So let's see how to do it. Very easy question. The question might look a little complicated, but it is not. We know the formula that the amount of heat lost or gained is equal to mc del T, where m is the mass of the object, c is the specific heat capacity, and del T is the rise in temperature or the change in temperature. So both of them have the same value of Q. So I can write that m1 c1 del T1 is equal to m2, or let me use the values as P and Q instead of 1 and 2. So mp cp del Tp, this is for the block P, is equal to mq cq del Tq. This is the values for the block Q. So we have been said that their masses are in the ratio 2:1. So I can take the mass of P as 2x and the mass of Q as 1x. So 2x into, we have to compare the specific heat capacity, so I am going to keep it as it is, and their rise in temperature is same, see. So I can just directly cancel it out, it is same. Okay, so this will be equal to x into Cq. So what will be the value of Cp by Cq? X by 2x, that is 1 by 2, or you can also write 1:2. So this is the ratio of the specific heat capacities. See, so simple. You just have to remember this particular formula, which you use extensively in solving numericals, and then you are done. Okay, let's move on to the next question now. This is from the chapter electromagnetism. Let us see. When a current carrying conductor is placed in a magnetic field, it experiences a mechanical force. You know about this. This thing would have been much more clear to you if you have studied about motors and generators. but since it is not there in your syllabus, you just have to know one thing, that whenever a conductor which is carrying current, it is placed in a magnetic field, it will experience a force which will help it to move, okay, preferably in a circular manner, but it is not always true. What should be the angle between the magnetic field and the length of the conductor so that the force experienced is 0 and maximum? So let us see. So we know one thing, that the force which is experienced by that current carrying conductor depends on a certain number of parameters. So using those parameters, using that relation, we are going to find out the answer to our question. So you know one thing, that the force is equal to ILB sin theta. I don't know whether you have the relation for sin theta in your book, but if you don't, I guess you have it till ILB. So sin theta is used whenever we want to find out the angle between the force and what has been said, between the force and the magnetic field. Yes, sorry, between the magnetic field and the length of the conductor, that means between L and B. Okay, so in the first case, 0. When is the value of sin theta equal to 0? For what value of theta? We know sin theta will be 0 when theta equals to 0, right? So when the value of theta is equal to 0 degree, the value of sin theta is also 0 degree, it is equal to 0, and as a result our force will be equal to 0. This is what was asked in the question, right? Now in the second part, we have been said that maximum. When is the value of sin theta maximum? When the value of theta is 90 degree, we know the value of sin theta is 1. That means our force will be equal to ILB. So this is the condition when the force will be maximum. Now you might ask why I am not taking values such as 30 degree and 45 degree. Okay, let me do it with 30 degree. Sin 30 degree is half, isn't it? So I am getting ILB by 2. Is it maximum? No. This is the maximum value, isn't it? Sin has a minimum value at 0 degree and a maximum value at 90 degree. So I am taking those two extreme values to get my answer. I hope it is clear. So in the first case it will be 0 degree and in the next case it will be 90 degree. Okay, then let's move on to the next question. This is from the chapter radioactivity, and this is also one of my favorite questions to solve. So let's see how to do it. So you have a nucleus, let me write it. X202 is its mass number and 84 is its atomic number. It emits an alpha particle followed by a beta particle. Okay, so what will be its so its final nucleus configuration is given YBA. You have to find the values of A and B. Okay, let's do it. So when it emits an alpha particle, we know what happens. Whenever an alpha particle is emitted, the mass number decreases by 4 and the atomic number decreases by 2. This video has been given in the short section in my channel, so you can just check it out. So let me consider the new nucleus to be Z. So the mass number is decreasing by 4, so it is becoming 198, and the atomic number is decreasing by 2, so it is becoming 82. Now a beta particle is emitted. So what happens when a beta particle is emitted? The mass number remains same, but the atomic number increases by 1. Make sure that you are hearing it increases. Don't make a mistake regarding this, okay? It is a little confusing, but if you practice, you will be able to remember it. So let me take it as X dash. So what will happen? The mass number is remaining same, so 198, and the atomic number is increasing by 1, so 83. So this is your final nucleus. So if you compare it with YBA, you are getting that A is equal to 83 and B is equal to 198. So this is your answer. See, so simple. So I hope this question is also clear to you. Now let us move on to the last question for today's live session. It is also from the chapter electromagnetism. So over here we have a current carrying loop, and we have been asked to find the magnetic polarity of the loop that faces us. That means if we are seeing from the screen, from the top of the screen, what will the polarity be for us? Okay, so let's see. We know one thing, that current will flow from positive to the negative terminal. So the current flow will be like this inside the loop. And you know, in order to find the polarity, you have to use the right end of N and S. So in case of N, you see it is moving in this direction or anti-clockwise. And in case of S, it is moving in this direction. The current is moving in this direction. That means clockwise. So in our case, in which direction is the current flowing? Clockwise direction. So the answer will be south. Now if the question was what would be the magnetic polarity for a person who would be inside, or who would be facing the loop from the other side. For that person it would have been north, but we have been said regarding the side which is facing us, so it will be south because it is moving in the clockwise direction, so it will be south. I hope this is clear. These two diagrams are given in your book, you can just check it out once. Now your next question is, with respect to the diagram, how can we increase the strength of the magnetic field? So over here we see that there is only a single loop, and obviously we cannot increase the number of turns, it is not a solenoid. So only one thing we can do is that we can increase the amount of current. So if we increase the current, the magnetic field produced will also increase in strength, increase the current. Okay, so I hope it is clear. So I guess today's live session was quite beneficial for you guys, especially for the ones who are preparing extensively for the examinations which are about to start. And if you have any doubts regarding the paper or regarding any other question, please make sure that you are sending your doubts to the mail given in the description box. And also join with us in the live sessions, because we are going to practice a lot of questions and I'm going to solve whatever doubts you have. And let's meet again tomorrow with section 2 of the same question paper. Till then, keep studying very nicely, because your exam is actually knocking at your door right now. So all the best and keep studying, everyone. Thank you for patiently listening to me and giving me your time. Bye bye, everyone.